Hello, and welcome to my first e-video. Today we will learn about 10.10 polynomial long division. In the last unit, we looked at simplifying rational expressions by factoring the numerators and the denominators, and canceling any term that appeared in both. So, for instance, we saw things that factored into maybe x plus 2 and x minus 3, and in the denominator we get x minus 3 times x plus 1. And what ended up happening is that the x minus 3 in the top and the bottom ended up canceling, because when combined together, they are equivalent to 1. That left me with the reduced form of x plus 2 over x plus 1. Today we're going to look at polynomial division, and we're going to begin by looking at how it relates to integers first. So let's look at exercise 1. The polynomial division, the long division algorithm is actually something that you should be very familiar with, and I've seen a lot of you work very well with it so far. To do that, what we do is we set up the division using the proper notation. So we're going to look at 1,519 divided by 7. We're going to start with that problem. Whatever's in the top goes underneath the division symbol, what's underneath goes outside. And the way we do this is we find a number to multiply to 7 that gives me 15. Well, nothing does that, but 2 is close, so 2 times 7 is 14. Subtract those, you get a 1. And you just repeat the process by bringing down the next integer, which is a 1. Okay, 7 times 1 gives us 7. Subtract those, it gives me a 4. Bring down the 9, 49. 7 times what gives me 49? 7 times 7 gives me 49. And subtract those, we get a remainder of 0. So the result when we divide 1,519 by 7 using long division gave me 217. And because it has a remainder of 0, no remainder, we know that 7 divides evenly into 1,519. Now, important to be able to do, and this will relate closely to what we're going to do with the polynomial expressions, polynomial division, is that it's sometimes nice to write them in multiplication form, meaning that 1,519 is going to be equivalent to what we get, 217 times what we divided by, times 7. Okay. Now I'm going through this pretty quickly because the long division algorithm should be something just a quick review for you. Okay, but pause the video if you need to. Now for part C, let's look at a slightly different problem. A slightly different numerator means we're probably going to have some kind of remainder. Let's do the long division to find out what we're going to get. Okay, let me make this a little higher up. So let's divide 1,522 by 7. Let's see what we get. Okay, again, using the long division, the long division algorithm, we get 2 times 7 gives me 14. Subtract them, gives me 1. Bring down the 2. 1 times 7 gives us 7. Subtract them, that gives us 5. Bring down the last 2. And 7 times 7 gives us 49. In this case, we end up having a remainder. So that means 7 does not divide evenly into 1,522. So there's several ways you can write your answer. One way is writing 217 remainder 3. Another way is as a mixed fraction, 217 and 3/7. Okay. I personally don't really like mixed fractions that much. Let me write that a little better. 217 and 3/7. I don't really like mixed fractions because to me they look like multiplication. Okay, and when it looks like multiplication, I want to multiply them, but that's not what that's saying. Okay, another way can we write it is, probably a better way to writing it is with addition. 217 plus 3/7. Okay. Now for part D, let's write the answer to there in multiplication equation. So that means that I can rewrite that 1,522 as 217 times 7. But remember, that did not make 1,522, that made the 1,519. So we have to add the remainder of 3. Okay? And that's how you write your answer using a multiplication equation. Pause the video now, write down anything you need to. Okay, exercise 2. Now let's see what happens when we do long division with polynomials. We're going to set up the equation in the exact same way we did before. Okay, but this time we're going to be putting polynomials underneath the radical sign. So 2x squared plus 15x plus 18 divided by the x plus 6. When we do it with polynomials, what we're going to do is we're going to look only at the first term of the polynomials we're looking at. Okay, so we're going to just look to see what multiplies to x to give us 2x squared. And to multiply the 2x to get 2x squared, we're going to multiply the x by the 2x. Once we find that value, then we multiply what we get by each of the terms of what we're dividing by. So 2x times x gives us a 2x squared. 2x times a 6 gives us a 12x. And I'm always going to line them up with like terms. Okay? And then I'm going to subtract them. So what we'll essentially be doing is you're going to be changing the signs. Subtracting them makes this a minus, makes this a minus. So those cancel, leaving with 15x minus 12x, which is 3x. Then we bring down the next term, plus 18. You're going to repeat that process until you are done. So you ask yourself, what multiplies with x to give me 3x? Well, 3 does. So I'm going to multiply that 3 with both the x and the 6 to give me 3x plus 18. And notice when I subtract them this time, I end up getting 0. No remainder. So that means using polynomial long division, my result was 2x plus 3. Now what that means is that that numerator could have been factored into one factor being 2x plus 3. So if you write this as an equivalent multiplication equation, that 2x squared plus 15x plus 18 is equivalent to 2x plus 3 times x plus 6. There was no remainder. We don't have to add anything to it. Okay. Pause the video now and write down anything you need to. Alright, letter C. Now let's look at an example where we have polynomial division that ends up with something that isn't evenly divided into the numerator. So, let's set up the division problem. 2x squared plus 15x plus 20 divided by the x plus 6. Again, you just want to look at the first term of each of them. What multiplies with x to give us 2x squared? 2x does. So I'm going to write 2x on the top. Then I'm going to multiply that 2x with both the x and the 6 to give me 2x squared plus 12x. Then I'm going to subtract those, so it changes the signs. The 2x squareds go away, but the 15x minus the 12x gives me a 3x. Then I'm going to bring down that plus 20. Then I want to ask myself, what multiplies with the x to give me a 3x? Well, a 3. Multiply it with the x plus 6 gives me 3x plus 18. Subtract them, I get a remainder of 2. Which means I need to write my answer using this notation. 2x plus 3 is what I got, but I had a remainder of 2, so I had to add 2 over x plus 6. Whatever the remainder is always goes over what we divided by. Okay. We could also rewrite this using the equivalent multiplication equation by saying that original problem, 2x squared plus 15x plus 20, the original numerator, is going to be equivalent to that 2x plus 3 times the x plus 6 plus 2, because there's a remainder of 2. Because that 2x plus 3 times x plus 6 didn't give me 2x squared plus 15x plus 20. It gave me what we got in part B and A, which is 2x squared plus 15x plus 18, but we have to add a 2 to make it equivalent. Pause the video now and write down anything you need to. Okay, exercise 3. Now let's practice this. So go ahead, try letter A on your own and see what you get. Okay, so let's check your work. Doing polynomial long division, we have x squared plus 2x minus 5 divided by x minus 3. Ask yourself what multiplies with x to give me an x squared. X does. So if I multiply the x by the x minus 3, you should have gotten x squared minus 3x. Subtract off both of those, change it to minus and change it to a plus, which gives me a 5x. Bring down that negative 5, because 2 minus negative 3 is positive 5. Then I ask myself what multiplies with x to give me a 5. 5 does, so I'm going to multiply the x minus 3 by the 5, give me 5x minus 15. And I'm going to subtract those by changing the signs, and that leaves me with a remainder of 10. So writing my answer in quotient remainder form, which is essentially what my answers have been written as, is x plus 5 plus remainder 10 over x minus 3. Okay, go ahead, pause the video now and try letter B, see what you get. Okay, so let's check your work. Setting up the long division, 2x squared minus 23x plus 17 divided by x minus 10. That little square does not look good, so I'm going to rewrite that. There we go, looks much better. Divided by the x minus 10. So what times x gives me 2x squared? Well, 2x does. 2x times x gives me 2x squared. Multiply with the 10 gives me negative 20x. Let's subtract those, leaving me with a negative 3x. Negative 3x plus 17. Bring down that 17. So what times x gives me negative 3x? Well, minus 3. Negative 3. Which when multiplied gives me negative 3x plus 30. Subtract those. That leaves me with negative 13 as a remainder. Now there's two ways you can write your answer in this case. Okay, if we do it like we did before, we write in the form with the adding the remainder, which will give me a 2x minus 3 plus a negative 13 over x minus 10. However, when we end up with a negative remainder, I think it looks a little nicer just to bring that negative out front to make a 2x minus 3 minus 13 over x minus 10. Both forms of an answer are completely acceptable. I just tend to prefer that last one, but any of them are acceptable. Pause the video now and write down anything you need to. Alright, exercise 4. Okay. Now, before we get to this exercise, I want to look at some things we've done in the past. When we canceled numerators and denominators in the past, in the last unit, we only canceled after we factored, meaning rewrite them as multiplication, because when you cancel things, you can only cancel things from the numerator if they're being multiplied together. So if we got something like x plus 3 over x minus 4, we could not have canceled those x's because they were being added to a 3 and it was being subtracted with a 4. Okay, that's bad. Okay, you can only cancel if they're being multiplied. Okay. However, there have been some problems in the past where we used the quadratic formula to solve an equation and we got something like 3 plus 6 radical 2 over 9. Okay, and when we simplified these, we looked at each term separately. even though being added, we looked at each term separately to find out the highest common factor that goes into all of them. Okay? We could also break this up into 3/9 plus 6 radical 2 over 9. Right? And then we simplify it accordingly. So if we have addition in the numerator, we can break it up into separate fractions all over the same denominator. Okay? And that's going to be an important thing to look at and to refresh ourselves on before we get to this next example. Okay? So let's look at exercise 4. Exercise 4, I can rewrite this expression x plus 8 over x plus 3 so it cancels nicely without having to do actual long division into that form. And the way I'm going to do that is, if I look at the x plus 8, I can rewrite that as x plus 3 plus 5. Okay? Because 3 plus 5 is 8. And you can rewrite anything you want to into an equivalent form. And that's an equivalent form. So I can rewrite this x plus 8 over x plus 3 as x plus 3 plus 5 over x plus 3. Okay. Using the fact that division distributes over addition, we can write our final answer, because we can group this x plus 3 together and the 5 by itself, and we can rewrite this as x plus 3 over x plus 3. Let me write that a little better. Plus 5 over x plus 3, just like we did when we were using the quadratic formula. Okay, we can break this added to this into two separate equations, both over x plus 3. What ends up happening is that this expression is equivalent to 1, so we get our reduced form 1 plus 5 over x plus 3. Nifty. All right, pause the video now and write down anything you need to. All right, moving on to the next lesson, next example. Exercise 5. So let's practice this with a little more challenging problems. In this case, I don't just have an x on the top, I have a 4x on the top. Okay? So I want to rewrite that numerator so that it has an x plus 2 in it. However, I want to write it so I have just a number in the top to remain. So what I'm going to do is I'm going to rewrite that 4x plus 13 as something that has an x plus 2. To make it just an x plus 2, notice I have to have a 4. But if I do 4 times x plus 2, that gives me really 4x plus 8, right? What do I have to add to 8 to get to 13? Well, I have to add a 5. So I can rewrite that numerator as 4 parentheses x plus 2 plus 5 over the x plus 2. That allows me to break up my fraction into 4 times x plus 2 over x plus 2 plus 5 over x plus 2, which allows me to cancel the x plus 2's, leaving me with just 4 plus 5 over x plus 2. Stylus pen is not working very nice today. There you go. 4 plus 5 over x plus 2. Okay, and there's my final answer in the appropriate form. Okay, go ahead, pause the video, try letter B on your own, see what you get. Alright, let's check what you got. So, if I'm going to rewrite the 3x minus 5 so it has an x minus 4 in the top, let's just check to see what happens when we multiply 3 times x minus 4. That gives me 3x minus 12, but to get a negative 5, I have to add a 7. That gives me a 3x minus 5. So I can rewrite this as 3 times x minus 4 plus 7 over x minus 4, which allows me to break it up into two separate fractions. I'll write it down here. 3 times x minus 4. Yeah, let me write that a little better. 3 times x minus 4 over x minus 4 plus 7 over x minus 4. And that allows me to write my final answer, because the x minus 4's cancel, as 3 plus 7 over x minus 4. Okay, pause the video now, write down anything you need to. Alrighty, so in summing up this lesson, okay, what we learned today is the long division. The long division. Come on. Okay, get out of there. We looked at the long division method of simplifying a rational expression. Okay, and we found our answer by writing it in some kind of a polynomial plus some remainder over what you were dividing by. Okay, and this is going to be probably a highly tested thing on the Regents exam at the end of the year, so it's a good thing to be able to do. So thank you for watching. As always, keep thinking and keep solving problems.